Alright, so if I look at this example, I want to do x plus 5 to the 4th power. So again, when I look at Pascal triangle, this is the 0 power, the 1st power, the 2nd power, the 3rd power, and the 4th power, which means I want to use this row of Pascal's triangle in order to solve this problem. So if I'm trying to use this row, I'm basically going to start off the same way every time. I'm going to write down the coefficients. So I'm going to write down these coefficients. So 1, 4, 6, 4, and 1. Notice I gave myself plenty of space between each of these. Now I'm going to fill in my A's and my B's. Just like I did on the previous page, I'm going to start, because this is to the 4th power, so I'm going to start with an A to the 4th and count down. A to the 3rd, A to the 2nd, A to the 1st, and then A to the 0 would just be 1, so I'm not going to write it. Okay? I do the same thing with B, but I start at the back end. So over here I do B to the 4th, B to the 3rd, B to the 2nd, B to the 1st, and then B to the 0 I don't write, and now I just fill in some plus signs in between here, okay? So this is the pattern that I'm going to prescribe to, except before that was talking about A plus B raised to the 4th power, and here instead of A and B, what I have is an X and a 5. So right here instead of A I have X, right here instead of B I have 5, so all I'm going to do is plug in X for all the A values, and I'm going to plug in the 5 for all of the B values. So here, this is going to be an x to the 4th plus, it's going to be a 4x to the 3rd times 5 plus 6x to the 2nd times 5 squared plus 4x times 5 to the 3rd plus 1 times 5 to the 4th power. Okay? And so what I have here is I basically have just a couple pieces that I need to simplify in terms of multiplying this out. And so when I look at the first piece, x to the 4th isn't going to change. It stays an x to the 4th. When I look at this second piece, I basically have 4 times x to the 3rd times 5. Well, I can multiply the 4 and the 5, and that gives me a 20. On the next piece, I have 5 squared, which is 25, and then I can multiply that by the 6, which is going to give me a 150 x squared. On the next one, I have 5 to the 3rd power and then times the 4. So that's 125 times 4, which is 500. And then the last piece, I have 5 to the 4th power, which is 625. Okay? So when I multiply all this out, it's going to give me this. And when we look at that, it seems maybe like that's a little bit complicated. But think about how much more difficult that would be to do x plus 5 times itself 4 times, okay? I'd have to do an x plus 5 times an x plus 5, and then I'd have to do another x plus 5 times an x plus 5, and then I'd get 2 trinomials, and then I'd have to multiply those 2 trinomials out. It would end up being more work than what we have here using Pascal's triangle, okay? And the higher the exponent, the more work that Pascal's triangle is going to save us. So if you remember the second example from the previous page was x minus 6 to the 7th power. So I'm going to need a couple more rows in Pascal's triangles. Right now I only have to the 5th power. This would be the 5th power. So I keep going. Again, I add the term next to it. So this is like a 1 plus 0, which is a 1. Here I do the 1 plus 5, which gives me a 6. 5 plus 10 gives me a 15. 10 plus 10 gives me a 20. 10 plus 5 is a 15. 5 plus 1 is a 6. 1 plus nothing is a 1. That's to the 6th power. I have to keep going. So I do 1 plus nothing is a 1. 1 plus 6 is a 7. 6 plus 15 is a 21. 15 plus 20 is a 35. This is going to be another 35, a 21, a 7, and a 1. So that's my 7th power. Here was 6th power. Here was the 7th power. So I'm going to write down those coefficients. And again, make sure you give yourself a lot of space on this. So 1, sorry, let me go back to blue here. So I write down the 1, the 7, 21, the 35, the 35, the 21, the 7, and the 1. Okay, I start off with my A values and I count down, so it's A to the 7th, A to the 6th, A to the 5th, A to the 4th, A to the 3rd, A to the 2nd, A to the 1st, and A to the 0. Now do the same thing with my B values going backwards. So B to the 7th, B to the 6th, 5th, 4, 3, 2, 1, 0. Okay? And then I just slap some plus signs in between here for now. Those signs might change based on the multiplication that I do, but I'm just going to slap plus signs in between there for now. And now I look at the original problem. remember, we were talking about this form. We were talking about a plus b to the 7th power. That's what I have written out right now. But instead of a, I have an x. Instead of b, I have a negative 6. So I just substitute in. So this is going to be an x to the 7th plus 7x to the 6th times a negative 6. And so I'm just filling these in. X to the 5th, that's going to be a negative 6 squared, plus 35, that's going to be an x to the 4th, and then a negative 6 to the 3rd, plus 35, x to the 3rd, and then a negative 6 to the 4th. And you can already tell that these numbers are going to kind of get out of control here very quickly as soon as I start doing, 6 to the 3rd power or 4th power. But you can imagine how much more difficult that would be if I was multiplying out 7 of these binomials and then having to deal with these numbers. It would be far worse. And so what we do here is we basically use our calculators to multiply all this out. And I've already done this ahead of time just because it would take forever to do in terms of video time. You'd get very bored here very quickly. So I multiply this out. The first one stays the same. That's x to the 7th. Notice I'm giving myself a little extra space. Then I get a minus 42 x to the 6th. Then I get a plus 756 x to the 5th. And then a minus 7,560 x to the 4th. See, as soon as we're just doing, negative 6 to the 3rd power, things are already getting a little bit ridiculous in terms of the size of the numbers. Plus, it's going to be a 45,360 x to the 4th. And you just multiply these out using your calculator. 163,296 x to the 2nd. A plus 326,592 x, and then a minus 279,936. Okay, so when we look at this thing, it looks kind of ridiculous when you think about the numbers that I have here. But the fact of the matter is, if I wrote out x minus 6 7 times and had to start multiplying out and foiling those binomials, this would be much, much worse. This would probably take up a whole page to do this. Okay? And so if we look at one more example, this is a kind of a simpleton example. If I was just doing to the 3rd power, and this is one we did on the previous page. But think about this. If I go and steal these coefficients, it's 1, 3, 3, 1. All right? So if I just do 1, 3, 3, 1, and this is one we can probably do without the calculator. A to the 3rd, a to the 2nd, a to the 1st, a to the 0, b to the 3rd, b to the 2nd, b to the 1st, b to the 0. I slap my plus signs in between. But now here, instead of a, I have a 3x. Instead of b, I have a negative 2. And so I plug these in. And watch what happens here. And this might end up being easier, or you might find this easier than what we did on the previous page. It's just a little bit different. And so as I start to multiply this out, this one's an easy one. That's a 27x to the 3rd. Here, that's going to give me a 9x squared times the 3 times the negative 2 is going to give me a negative 54x squared. The next one, I've got the negative 2 squared is a positive 4 times the 3 times the 3x. That's going to be a 36x. And then this last one, negative 2 to the 3rd power, is a negative 8. And if we go back and check that, that should be the same answer we got on the previous page. But again, this is just another option, another way of doing it. You could multiply that out 3 times, and so there's a little bit of a threshold here where you have to decide, okay, would this be easier to multiply out the binomials, or would it be easier to use Pascal's triangle? Okay?